Assalamualaikum and good day everyone. My name is Raja Farhana and I will be presenting my final year project with a title of Application of Pectin Extracted from Fruit Waste in Cosmetics, a review. So this is the outline of my presentation. We will start with introduction followed by literature review and conclusion and recommendation. According to Mary et al. 2018, around 100,000 kg of food waste and byproducts are produced yearly by the food processing industry. Dalal et al. 2020 states that in 2013, fruit waste amount for 16% of all food waste. Fruit processing waste are widely acknowledged as a significant environmental problem that affects the whole world, especially considering that landfilling is the standard and the most often used technique of disposing of trash with a high moisture content due to economic considerations. The proper exploitation of fruit waste and byproducts offer enormous potentials for acquiring functional food additive or as phytochemical pharmaceutical materials. In research from Tudor et al. 2021, biopolymers, particularly pectin, which has an annual global usage as an addition of roughly 16 million kg in 2018, are abundant in the waste produced by agro-food industry. Pectin are the most abundant polysaccharides of the main cell wall. The word pectins does not classify a single cell wall polymer. Instead, it is a class of polysaccharides or glycan domains which includes galacturonic acid residue connected at both 1 and 4 positions. As we can see from figure 1, it is composed of structurally different domains such as homogalacturonan, silogalacturonan, rhamnogalacturonan 1 and rhamnogalacturonan 2. Homogalacturonan is the most common pectin polysaccharide in primary cell walls. It is accounting for roughly 65% of pectin. It has 1,4-linked D-galacturonic acid backbone. Silogalacturonan are homogalacturonans replaced by beta-linked D-xylose 1,3 at O3, which in turn is sometimes replaced at O4 with an additional beta-linked D-xylose. It have mostly been discovered in reproductive tissues such as fruits and seeds, and its purpose are for storage and reproductive plant organs. Rhamnogalacturonan 1 has been discovered to have backbone involving diglycosyl reputations that have numerous side chains connected to O1 of the L-rhamnosyl residues. The commonness and structure of the rhamnogalacturonan side chains differ significantly between the different cell types, stage of developments, and species. Rhamnogalacturonan 2 is a pectin domain that has been discovered in plant cell walls. It has a variety of roles and quantity of rhamnogalacturonan 2 in vascular plants has risen through time. Plant development may be influenced by rhamnogalacturonan 2 cross-linking, which affects the porosity and mechanical characteristic of primary cell walls. Cosmetics refers to all outward preparation for cleaning, softening, coloring, and protecting the skin, hair, teeth, and lips in order to preserve and beautify the body. Gelatin is a product made from collagen produced from animal skin, white connective tissues, and bones that has been partially hydrolyzed. It becomes an issue among the consumers as they are skeptical of the halal status of the product. There are many individuals around the globe who are vegetarians as well as the Hindus who do not consume gelatin with animal sources. As fruit plays an essential part in our nutrition, the demand for fruit has increased along the increasing of global populations. This has resulted in the increase of fruit waste that can cause pollution to environments and if it is not controlled, could worsen the pollution. The research questions in this review paper are: what fruit contain large amount of pectin? Which part of fruit waste that produce large amount of pectin? What are the biological activities of pectin? What are the methods used to extract pectin from fruit? And lastly, what is the function of pectin in cosmetic product? Now let's take a look at the type of fruit that yield large amount of pectin. From the table, jackfruit peel yields the highest percentage of pectin with 38.42% among the fruit waste, followed by citrus peel, apple pomace, dragon peel, mango peel, banana peel, papaya peel, and pomegranate peel. The pectin content in fruits is also affected by cultivar, maturity, and extraction conditions. For the part of fruit waste that produce large amount of pectin, the jackfruit seed slimy sheath Pectin extracted by the acidic extraction using oxalic acid resulted in the modest recovery pectin of 35.52%. According to the Sundaraj et al. 2018, extracted jackfruit peel pectin using organic acid achieved the highest yield of 38.4%, while apple pomace extract pectin by using acetic acid extraction yield only 19.60%. Therefore, pectin extracted from peel yield the highest percent. For the biological activities of the pectin, Nguyen and Pirat 2019 in their research used DPPH and ABTS radical scavenging assay in order to evaluate the properties of the antioxidant from dragon fruit pectin prepared with various conditions. The result shows that the antioxidant activity of dragon fruit peel for both conventional extraction and ultrasound assisted extraction by DPPH and ABTS are higher than the antioxidant activity of the commercial pectin. Therefore, it can be concluded that pectin has antioxidant effect as it yields significant amount of antioxidant properties. The antimicrobial effects of phytochemical compounds that are found in plant extract can be studied by observing the inhibition zone. In research conducted by Nisar et al. 2020 found that citrus pectin film integrated with 15%, 1.0% and 0.5% of clove bud essential oils shows good antimicrobial activities against Staphylococcus aureus, E. coli, Listeria monocytogenes, as it can inhibit the growth of microorganisms. The extraction of pectin is a physical chemical process that involves several stages of hydrolysis and extraction of pectin macromolecules from plant tissues as well as their solubilization in bulk solvent. All of it occurred in a continuous manner under the control of various process parameters, primarily temperature, pH, and time. Based on the presented data, we can see that most of the method requires acid as their solvent, and the results varies depending on the methods and type of the solvent used to extract the pectin. The hydrolysis of protopectin, the parent material from which pectin is formed, requires acid. Acid is used to break down the cell wall components, separate the cellular contents prior to extraction. From the data, conventional heating extraction method with citric acid produce the highest percentage yield of pectin extracted from fruit citrus peel, followed by ultrasound microwave assisted technique and acidic condition by using citric acid with 39.13, 36.33 and 24% respectively. In cosmetic and other personal care products, the pectic compounds can be effectively blended with other chemicals that have been found to be beneficial against a variety of skin disorders. Pectin is a chemical compound in most fruit that is known for its binding and gelling abilities. In hair products, such as shampoo, pectin can help strengthen strands and add shine while also achieving a deep clean by helping to remove dirt and product build-up. In conditioners, pectin provides more intense hydration of the hair and it acts by enhancing the sensation of softness promoted by the cationic surfactant, besides helping the improvement in the compatibility performance and make the hair shine. As a conclusion, pectin extraction is capable to substitute gelatin because they contain vast of properties like gelling agent, thickening and stabilizer. Not only that, by using pectin, we can reduce the amount of fruit waste as we utilize the fruit waste to get the pectin. As for the recommendation, based on the research that have been made, pectin is very well qualified to be put into cosmetic product as it is very safe to be used and safe for the environment. Yet, there is still not many researchers has made a deep and intense research on the pectin function incorporated in cosmetic, though pectin is easy to obtain and will not harm the nature. Therefore, exploration in pectin surely needs to be done so that it can completely reduce the animal-based product such as gelatin and reduce the food waste that can cause environmental pollution at once. And lastly, here I present my reference. So this is the end of my video presentation. Thank you for listening.